Alright, so we are going to talk about our next topic, and this is a follow-up topic from our first topic, which is the finding derivative of our algebraic function. And this part, we are going to tackle our higher order derivatives. So you will learn how to get the higher order derivatives of an algebraic function. And how can we find for the higher order derivatives of an algebraic function? To find the nth order or any number, any order of derivative, you just take the derivative again and again if necessary. So for example, to get the fourth derivative, so from the f prime function of x, or the first derivative, you would just take the derivative of f prime x 3 times before you could arrive to the fourth derivative. See? And here are the notations that you can be able to encounter when you are tasked to get the higher order derivative. We are using y prime, f prime of x, dy over dx, and d over dx times y, or d over dx times f of x, or d sub x times f of x. And when we get the second derivative of that, you'll just have to, it will take, just take a look at here, and it will look like y prime prime order to b. It means that you're looking for the second derivative, or f prime prime of x, or just d squared. There will be exponent of 2 because, as I mentioned, you are looking for the second derivative. So d squared y over dx squared, or d squared over dx squared times y, or d squared over dx squared times f of x, or d squared sub x f of x. And it will continue until to what order of the derivative you are looking for. And as you can see, these two notations are only the popular that we are using, or the popular notations that we are using. The f prime prime, or the f of x, or f prime x, like that. And then the other one is dy over dx. Now let's move forward to our first example here. Given that we have the f of x is equals to 3x raised to the fifth power minus 2x cubed plus 14. So we are tasked to find that third derivative, since we have 3 primes here, f prime 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 of x. And since that we need to get the derivative, or the third derivative, this first step that we need to do is to get the derivative of each term. And on this part, we can apply the constant multiple rule. Say, for example, here on the first term, we have 3x raised to the fifth power. Then the exponent 5 will be multiplied to our base 3. Then it will look like 15x to the fourth power. Because we have 5 as our exponent, we need to subtract 1 from 5. That's why we only have x to the fourth power. And for our second term, 2x cubed. So we need to multiply this exponent 3 to 2. Then we have 6, and then the exponent 3 minus 1 is 2. That's why we have 6x squared. And since that the third term is a constant, and according to the constant rule, the derivative will be always equals to 0. That's why we only have two terms here. 15x to the fourth power minus 6x squared. This will be for our first derivative. And we will continue to get the derivative again of this first derivative for us to arrive on our second derivative. And we are going to get the derivative of each term again. Say we have 15x to the fourth power. What we're going to do is to multiply the exponent 4 to 15. That's why we have 60 here. And then subtract 1 from 4, we have 3 here as for our exponent in our variable x. So we have 60x cubed. Same goes like this. Just apply the constant multiple rule. 2 times 6 is 12. And then the exponent 2, I just subtract 1 from it. Then we only have one exponent. That's why we only have x here. Then our second derivative will be 60x cubed minus 12x. Now, let's move forward to finding the third derivative. Just apply again the constant multiple rule. 3 times 60 is 180. Then minus 1 from the exponent. Then we have x squared minus 12. Since we only have 1 as our exponent for variable x, just subtract 1, then we don't have any exponent at all. That's why we only have constant here. And then the final answer for the third derivative of this function is 180x squared minus 12. Let's move forward to our next example. Say I have here the given f of x is equals to 2x plus 1 all over 3x minus 2. So we are asked to get the second derivative. Since we have quotient division here, we need to use the quotient rule for finding the derivatives. First step is, of course, get the derivative of the numerator, 2x plus 1, that will be 2, multiply to the denominator, 3x minus 2, minus, get the derivative of the denominator, then we have 3, and then multiply to the numerator, 2x plus 1. And then just square the denominator. That's why we have the quantity 3x minus 2 squared. And we use the quotient rule here. And next is we need to distribute so that we can perform this. So we have 2 times 3x is 6x. 2 times negative 2 is negative 4. Then we have negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Then copy the denominator and combine like terms. Since we have positive 6x here, negative 6x here, just cancel this 2. Then we have negative 4 minus 3. The answer will be negative 7 all over 3x minus 2 squared. Since this is in a fractional form, we need to transform it into a non-fractional form, or just an exponential form with negative. It will look like this. Negative 7 times the quantity 3x minus 2 raised to negative 2. Since that we transform this term into non-fractional form, that's why the denominator 3x minus 2 squared will become 3x minus 2 negative raised to negative 2. Since we've already got the first derivative, then we need to continue the process, get the derivative again, and for this time, since we have negative 7 times the quantity 3x minus 2 raised to negative 2, we are going to use the chain rule. First thing is we'll just have to multiply the exponent negative 2 to our base negative 7. That will be negative 14, and then subtract 1 from negative 2. That's why we have negative 3 as our exponent. And then multiply to the derivative of this quantity. The derivative of 3x minus 2 is 3. And then, next thing that we need to do, so we need to multiply 14 to 3. Then 14 times 3 is 42. And then transform the equation into fractional form. That's why our quantity 3x minus 2 raised to negative 3, it goes down here, became our denominator. And the exponent will be positive. Since we are looking for the second derivative with the function 2, we need to substitute 2 to our variable x. And it will look like this. 42 all over 3 times 2, because we substitute 2 to our x, minus 2, and then cube. Then just perform the denominator. 3 times 2 is 6. Minus 2 is 4. That's why we have 42 over 4 cube. And what will be the 4 cube? It will be 32. So our final answer for finding the second derivative with function 2 is equals to 42 all over 32, or 42 over 32. Now let's take this third example. Say we have the given, we have the third derivative already in our given, which is 2 square root of x minus 1. We are tasked to find the fourth derivative. So it's so easy since we are just going to get the derivative once, since we have the third derivative already in our given. And the first thing that we need to do is to transform this radical equation into exponential form. And it will look like third derivative with function of x is equals to the quantity x minus 1 raised to 1/2. Since we transform the radical equation into exponential form. And next step that we need to do is to apply the chain rule again. Multiply the exponent 1/2 to our base 2. And then get the derivative of this x minus 1. Then multiply. We need to multiply. That's why we have 2 times 1/2 times x minus 1 raised to negative 1/2. Where did negative 1/2 came from? Came from 1/2 minus 1. And then multiply to 1 since the derivative of x minus 1 is 1. And then just perform since 2 times 1/2 is 1, and we have 1 here at the end as well. The final answer will be the fourth derivative is equals to x, or the quantity x minus 1 raised to negative 1/2. That's so easy. We're just getting the derivative again and again until we got the nth order of derivative. Now let's see this fourth example. Say we have the given f of x is equals to 5x cubed minus 3x squared plus 10x minus 5. And then we need to get the fourth derivative. So from the first derivative up to fourth derivative, we are going to get the derivative 3 times. And first step is to get the derivative of each term again. Since we have this kind of equation, we can use the constant multiple rule. So for the first term, for 5x cubed, just multiply the exponent 3 to base 5, we have 15. And then the exponent 3, deduct 1. That's why we have x squared only here. And then minus 2, 3x squared, the derivative will be 6x. Just multiply the exponent 2 to 3, and then we have 6. And then the exponent 2 here, we deduct 1 or we subtract 1. That's why we only have x as our variable. And then since we have 10x here, so it will be, or the variable for 10x will, for the derivative for 10x will be 10. Since we only have 1 as our exponent, multiply to 10, we have 10. And then subtract 1 from that exponent, 1. Then we don't have any exponent at all. That's why we don't have any variable here. And then on our last term, we have negative 5. And from what the constant rule says, any derivative for constant is always equals to the 0. That's why we don't have the derivative for the last term here. And just continue the process, get the second derivative. So just apply again the constant multiple rule. 2 times 15 is 30, and then x squared, we have the exponent 2, subtract 1, then we have only 1 as our exponent, that's why we have 30x. And then the derivative for 6x is 6. So we got the second derivative, which is 30x minus 6. And then let's move forward in getting the third derivative. So from 30x, since we only have 1 as our exponent in our variable, when we subtract 1, then we don't have any exponent at all. That's why the only remaining term here will be our constant 30. And since we have constant negative 6, from the constant rule of differentiation, it will always equals to 0. That's why we only have 30 here. And then last getting of derivative, we're going to get the fourth derivative. Since we are only having here 30 and 30 is a constant, it means that our fourth derivative is equals to 0. Means why 0? Because 30 is a constant already. Right? So it means that from the constant rule, we'll just have the answer 0 for any constant. When you're getting the derivative of that, it will always equals to 0. Now let's see the fifth example. Determine the fourth derivative of f of x is equals to 4 fifth root of x cubed minus 1 over 8x squared minus square root of x. And first thing that we need to do in order to get to the fourth derivative is to make this radical equations into exponential form and the fractional form into non-fractional form. For our first term, 4 fifth root of x cubed, it will become 4x raised to 3 fifths minus 1 over 8x squared. Then we just get the constant out, so we have 1 over 8 times x raised to negative 2. And then minus square root of x, it will become x raised to 1/2 for our exponential form. And to find the first derivative, of course, we need to get the derivative of each term. And we are going to use again the constant multiple rule. We have 3 fifths as our exponent for x here. Then just multiply to our base 4. Then we have 12 over 5. And then our exponent for x will be negative 2 fifths because we subtract 1 from 3 fifths. That's why we only have x raised to negative 2 fifths. And then we have minus 1 over 8x raised to negative 2. Since we have exponent negative 2, multiplied to negative 1 over 8 will be negative 2 over 8 or, positive 2 over 8 or positive 1/4. That's why we have plus 1/4 here. And our variable x, since we have negative 2 in our exponent for variable x, we just have to subtract 1, then the answer will be negative 3. And let's move forward to our last term. So we are going to use power rule here. Then 1/2, just put it here, the side here. And then our exponent for x will be negative 1/2. Why negative 1/2? Because 1/2 minus 1 is equals to negative 1/2. So we have the first derivative already. And let's take a look and see the second, the second derivative. Just continue the process again. Use the constant multiple rule. So we will have the exponent negative 2/5 multiplied to our base 12/5. It will become negative 24 all over 25 x, and then our exponent negative 2/5 will become negative 7 over 5 because we subtract 1 from negative 2/5. And then let's move forward to our second term, 1/4 x raised to negative 3. So negative 3 times 1/4 is negative 3/4. Then our x raised to negative 3, the exponent, subtract 1 from negative 3, and it will become negative 4. And for our third term, we have 1/2 x raised to negative 1/2. And then we need to multiply negative 1/2 to our negative 1/2. Then we will have positive 1/4. And our exponent negative 1/2 will be, turns out to be negative 3/2 because we subtract 1 from the exponent negative 1/2. That is why we have x raised to negative 3/2. So we're done with the second derivative already. And then next is what we're going to do. Just continue the process to get the third derivative. So negative 24 over 25x raised to negative 7/5. So we this exponent negative 7/5 multiplied to negative 24 over 25. We get 168 over 125. X raised to negative 7/5 minus 1 is negative 12/5. Plus our second term na the 3 over 4x raised to negative 4. The negative 4 times negative 3/4 is positive 3. And then x raised to negative 4 minus 1 will be x raised to negative 5. Then for our last term, 1/4 x raised to negative 3/2. Multiply negative 3/2 to 1/4. Then we will have negative 3 over 8. And then our x raised to negative 3/2 will be negative 3/2 minus 1 will be negative 5/2. So our third derivative will be 168 over 125x raised to negative 12/5 plus 3x minus 5 minus 3x raised to negative 5, and then minus 3 over 8x raised to negative 5/2. And now we're one step ahead. So we're going to look for the fourth derivative now. So just multiply this exponent negative 12/5 to 168 over 125. That's why we got the answer negative 216 over 625. And then our exponent negative 12/5 minus 1, it will become negative 17 over 5 for as our exponent for variable x. Then for our second term, since we have 3x raised to negative 5, multiply the exponent negative 5 to our base 3, we have negative 15. And our exponent negative 5 minus 1 will be equals to negative 6. That's why we have 15x raised to negative 6 as for our second term. And in our third term, we have negative 5 halves for our exponent in our variable x. Then multiply to negative 3/8. That's why we have 15 or positive 15 over 16. X raised to negative 5 halves minus 1 is equals to negative 7 halves. And this will be our final answer. Our fourth derivative for our given will be negative 216 over 625 x raised to negative 17 over 5 minus 15x raised to negative 6 plus 15 over 16x raised to negative 7 halves. And again, I just wanted to let you know and make sure to remember that when you're solving for the higher order derivative, you'll just have to get the derivative again and again if necessary for you to get the nth order of the derivative. And first step that you need to do is to always get the derivative of each term. And if ever it's a division, of course, you need to apply the quotient rule. If it's a multiplication or a product of any variable, you need to use the product rule. If it is a sum or a difference, you need to use the sum rule, or you also need to apply the constant rule, constant multiple rule, constant rule, and product rule. And don't be confused whenever there is a radical equation or a fractional form equation. Make sure to transform it with an exponential form for you to easily get the derivative. And for your own practice, you can answer this. So, find the third derivative of f of x is equals to 5x to the fourth power minus 3x cubed minus 7x squared minus 9x plus 2. Second is find the third derivative of the function of 4 if f of x is equals to square root of x. You can try this for you to be able to practice on how to get the higher order derivative. And that will be all for our topic. Thank you.